So, option number one gives you three ways to fill the array: N-way, line scan, flood fill, and breadth first search or BFS. I'm going to be covering BFS. This is, I think, the one that you guys should be using for this assignment. It's the definitely the most efficient way, but you're free to choose whichever one you want to. So for BFS, we're going to need a queue, which I have set up here, and you are allowed to use standard queue. And then, of course, you need your array to fill. All of these elements should be initialized to 0. In your guys' assignment, you'll have like -1s sprinkled in here occasionally. So just assume if this space is blank, it's a 0. So to start it off, we will increment our starting location. I'm going to choose 0, 0, and we're going to push that onto the queue. So now what we'll do is we will pop off 0, 0 from the queue. So whatever that first element is, we'll pop it off. And we'll take a look at its more neighborhood. And that's what I have with this blue box over here. So this is 0, 0's more neighborhood. What we'll do is for each element in the more neighborhood, we'll take a look around and we'll see, is it a 0? If it is, then we'll take our element right here, increment it by 1, and that's what that element is going to end up being. So let's take a look at how that works. So let's start out with this one here. This one is a 0. So what we'll do is we'll take this 1, add 1, and make that element. So now this is 2, and we'll push on 1, 0 to the queue. 1, 0. And we'll do the same for 1, 1, and the same for 0, 1. So this is now 0, 1. All right, now we are done with this guy's more neighborhood. So we can remove that from the current, and we'll pop off the next thing from the queue. So the next thing is 1, 0. So what we'll do is we'll take a look at 1, 0's more neighborhood. So that is this guy here. And we'll find all the values that are 0. So in this case, we have 2, 0. That is a 0. And we'll push that onto the queue, 2, 0. And remember, we're incrementing whatever is in this index, what we're checking the more neighborhood of. We'll increment that, and that's what we're setting all of these values to. So we just pushed on 2, 0, and we'll push on 2, 1. Cool. So again, done with this guy. So we'll take him out of the current. And we'll move the more neighborhood. And we'll pop off our next element from the queue, which happens to be this 1, 1 value here. So now we'll inspect our 1, 1, which is right here. So with 1, 1, we'll do the exact same thing that we've been doing. So this is the first 0 value. We'll push on 2, 2 to the queue. Then we'll push on 1, 2. And we'll push on this 0, 2 here. Okay. So we're finished with that more neighborhood now. And like we've been doing, we'll move on to the next one. So the next one is a bit special. It's this 0, 1 here. So let's move it into the current and inspect its more neighborhood. So 0, 1 is right here. There's nothing that we can do here. Nothing to increment. All of these values are something that's not 0 or not -1. So we're just done with that. We don't have to do anything. We'll pop off the next value from the queue, which is this 2, 0. And I'm going to move this down to make a little bit more space for myself. So now we'll start inspecting 2, 0, which is here. And again, same process. We'll increment this to a 4, this to a 4, push these two values onto the stack. So that would be 3, 0 and 3, 1. And I think you guys get the picture at this point over like sort of what's happening here. So let's move on now to the greedy algorithm, sort of how you're actually going to be making a path. So I'm going to fill in the rest of this array. This is what it'll end up looking like if we continue on that breadth first search. And let's just go up till 6. All right. So for the greedy algorithm, we're essentially going to be starting at our largest value, which happens to be this 6. This is going to be our start, and all it does is it looks at the more neighborhood and finds the smallest value and moves to that. So in this case, our smallest value here is this 5. So we'll update our position and move it over to that 5 there, if this will cooperate with me. There we are. All right, so now we're on the 5. We'll inspect this entire more neighborhood, and the 4 is the closest. So far we've traversed from the 6 to the 5, and we'll move this over to here, and I guess I'll drag that 6 along. Okay. Apparently these didn't get locked. There we go. And that one's still not locked. Damn. All right. So we moved over to the 4 here. All right, so again, we're going to do the same thing. We're going to inspect this more neighborhood, and we're going to see what the smallest value is. It's the 3, so we'll move on to the 3. Inspect the more neighborhood, it's the 2, move to the 2. Inspect the more neighborhood one more time, and we move to the 1. And now we've finished our path. So if we traced it out, it essentially went like this.